Okay, today we're going to talk about chemical change and physical change. First, let's start off talking about chemical properties. Chemical properties involve how matter tends to behave when it contacts other matter. It's hard to talk about chemical properties without talking about chemical change because it implies the tendency to change. So words that might clue you into reference to chemical properties are if a substance is reactive, if a substance is inert, if a substance has a tendency to rust or combust or oxidize. It would be the tendency to perform a certain way in a reaction, whereas chemical change is that actual change then. So once a chemical reaction has progressed, a chemical change occurs, meaning one or more substances are now changed into different substances, so they've been rearranged. So words that might clue you into rearrangement are cooking, digesting, rotting, rusting, oxidizing, burning, things like that. Okay, on the flip side, we have physical properties. So physical properties are properties that can be measured without changing the matter's chemical nature, in other words, without undergoing a chemical reaction. So things like some things odor or color or volume or state of matter, if they're a solid, a liquid, or gas, or how dense the object is. If you remember the aluminum density lab, that was a physical property of aluminum, and it didn't change even if we had a different shape. It stuck with it. Melting point, boiling point are another examples. And then physical change is another similarly related thing that is just meaning that a change that only affects physical property. So if you just change the matter without chemically reacting it to form something new, for example, if you hammer it into a thin sheet, if you scrunch it into a ball, if you stretch a rubber band, if you stretch out a coiled wire, if you tear a piece of paper in half, even phase changes, so melting a substance or boiling a substance, you're not changing the physical makeup, the chemical makeup of the substance, you're just changing the physical shape or state that it's in. Okay, so just to lay those two side by side, chemical versus physical changes then. Physical change, you have just a different form but the same substance, no difference in composition, how the elements are connected. And the effective temperature can usually be reversed, so we pretty much mean phase changes here, that if you have a different, say if you have a solid versus a liquid for a gas, and you had to heat up a solid to liquefy, then if you cool down the solid, if you cool down the liquid, it would re-solidify. So you can change it back easily through a physical change. Chemical change leads to a different substance, so we have a totally different composition, and here the effect of temperature usually cannot be reversed. So this is important because, let's think, for example, of a match. If you were to burn a match and then say you added heat then to get that chemical reaction going, if you reverse that, if you put a burnt match in the freezer, it's not going to spontaneously regenerate the unburned match. So that's what we mean by usually cannot be reversed. Okay, so here's a good example of water, our go-to substance, that is undergoing either a physical change on the left, where we're just showing the freezing of liquid water into the ice sheet there, and then on the right we are showing how if a current is passed through it, now liquid water changes into two different gases. If you look at the tube on the left here, that's this one is producing, it looks like twice the amount of gas as this one. So we would imagine, since the formula of water is H2O, I would guess that this tube here is the hydrogen and this tube here is the oxygen. Let's look at the telltale signs of a chemical reaction. So how do you tell? How do you know if something is undergone a chemical reaction? So here are some things to look out for. So first thing is evolution of a gas. This can be seen by either if the substance starts to bubble or if an odor is formed. The second is the formation of a precipitate. This is when you have mixed two liquids together, like shown in the picture, and you get a solid that forms. If you can see this kind of grainy like solid that's forming in here, that's called a precipitate. So that we call that an insoluble solid. And that sometimes happens, so that is showing a chemical reaction. Accompanied with every reaction actually is either the absorption or emission of heat. And so we call evolution of heat an exothermic reaction, and we call the absorption of heat an endothermic reaction. And both are examples of a chemical change occurring. Not too common, but some reactions produce light as well as heat. And so, for example, bioluminescent tides, which is shown right here, hopefully you can recognize this guy, it's a firefly. And so they both have a chemical called luminol, and that a chemical, when it undergoes a chemical change, it emits light. So that's another example of a chemical change. Okay, then we have a color change. So here we have yellow and a clear solution making a dark orange solution, and we have a metal and a liquid producing a blue solution. So we're not talking about if you mix green and clear and you get lighter green, that's not a color change, but if you get a different color that forms, then that's evidence of a chemical reaction. Okay, so just to recap, physical properties that a substance shows by itself, doesn't interact with another substance to show it. So something's color, its melting point, its boiling point, its density. And a chemical property is a substance, the substance would show as it interacts with other matter, and things like the tendency to corrode or to be flammable, things like that. And here's a nice side-by-side showing copper, and on this side you're seeing like the physical properties of copper, and here are the chemical properties of copper. So a physical property might be that you can, bend it into sheets, that it conducts heat, and just its properties like its density and stuff like that. But here this is showing like it corrodes with oxygen, and it reacts with nitric acid, or it forms a deep blue solution, a color change. So those would be all examples of chemical change. So what's happening on like the microscopic versus macroscopic level? For macroscopically, if we're looking at physical change over here, the substance is the same, so the matter is the same. The original matter is still present and can be recovered by physical means, so like heating. And microscopically, the particles are rearranged in some way, but they do not form a new substance. Chemical change on a large scale level, the matter is different, so it's going to probably look different, and then the original matter is no longer present in the same form, and usually it cannot be recovered by physical means. There are some exceptions to all of this, but we're going to focus on the rule, not the exception. And then microscopically, particles of the substance are broken apart, so they're actually not just in a different shape, but they're detached, and the atoms are arranged now and rearranged in a new substance. Okay, just to look at this items on this list, if you looked at aluminum foil is cut in half, hopefully you would imagine that is a physical change. You fry an egg, that's a chemical change. Bread becomes toast, chemical. Water evaporates, that's physical. You break a window, that's physical. Milk goes sour, so it's decay, that's going to be chemical. And clay is molded into a new shape, that's physical.